Hey guys, Mr. Beeler here. Today we're talking about starters. So we've talked batteries, we've talked some basic electrical stuff. We're moving into starters. Starters, basically in the name, they are there to start the vehicle. They crank the engine over. So we have a drive gear, which meshes with our flex plate or our flywheel. There's a mechanical advantage. You can see how many teeth are on the flywheel versus how many are in the drive of the starter, which allows it to have a mechanical advantage to crank that engine over and get it started. Our components in the starter, this is one of our cutaways we've had from the school. We have the starter drive. Now this drive, if I try to turn it this way, it won't go. It will roll the other way. This has a one-way clutch in it. That one-way clutch, so when the vehicle starts up and the engine RPM comes up, allows it to spin in one direction without hurting anything inside the starter until it kicks back in. If you have one and you can turn it both ways easily, that drive is bad. Most likely when you try to start that vehicle, you'll hear the starter motor spin, but the engine won't crank. On this unit, this is a gear reduction starter. It's got a smaller electric motor in it. So it runs this small gear, which runs another bigger gear, which creates another gear reduction. We have the starter solenoid, which helps kick the drive out. It also makes contact run voltage to the starter motor itself. Inside we have the armature. It's a series of windings. This turns into an electromagnet when we energize it. We have brushes, which allow voltage to get from the solenoid contacts to the armature through the commutator. This is a permanent magnet type starter. There are magnets in here. To understand the basic principles on electric motors, I got a couple of magnets. As you guys know, I'm sure you played with them in elementary school. Magnets, depending on which poles you have, will repel or retract. So right now these two are repelling. So if I could put magnets in a starter or an electric motor and make them push away from each other or pull towards each other, I can make rotation happen. I can do that with an electromagnet. So as we run electrons through a conductor, there are magnetic lines of flux that are created. As these magnetic lines of flux interact with another magnet, they will push away from each other or pull towards each other. So if we can go through, and this is an armature out of another starter, if I can go through and energize different sections at different times, I can move my magnet around the starter, basically, and it'll interact with the magnets in the case, allowing that armature to spin. We have brushes that make contact on this commutator. So we send voltage in, this turns into electromagnet, different sections. As it rotates, it moves to the next section, turns that section on, and keeps this thing spinning. So again, we're back to magnets pushing or attracting. Oh. There we go. So we have to have magnets and electromagnets. Now some starters, this little Honda starter, this one is a permanent magnet starter. It has magnets inside of it. My screwdriver sticks to the inside of it. So pretty simple. There's magnets in that part. Our armature, again, we turn it into an electromagnet and vary where it's at so it'll keep the armature spinning. As the armature spins, this guy's got a little gear on the end. In the nose of our starter, this one's also gear reduction. It has a planetary gear set. So it spins that guy. So as the armature spins, our starter drive will turn. This has a gear reduction, has a mechanical advantage. Again, we have our drive gear. It has a one-way clutch in it. Something else that happens in these, there are bushings at each end. So at this end, at the back end of the armature, we have a bushing and a shaft that fit together. This one has very few hours. I don't know if it's ever been used. It's still pretty tight. You'll hear guys saying, hey, beat on the starter to get it to start. What happens is that bushing gets play in it, and this thing can get sloppy. And this moves around, and where our brushes make contact with the commutator, they're not making contact. You smack it, it jiggles around, it makes contact, starts spinning. The vehicle will start. You can move the vehicle. The downside of that is if you beat on a permanent magnet starter, you can crack the magnets on the inside of it. You crack the magnets, they get weaker, they don't work right, the starter's junk. So beware if you're beating on a starter. Now, beating on starters back in the day, this is out of a Fiat Spider I had. This has field coils in it. So this has actually more electromagnets in it. So when they energize that starter, those turn on. We have the armature of that one. You see the size difference. That Fiat starter was for a 1.8 liter twin cam Fiat engine. This is a direct drive. There's no gear reduction. Whereas the little Honda had a gear reduction. A lot heavier, a lot bigger unit. So again, there's our gear. This one has a one-way clutch, only rotates one direction. Our armature. Inside here you can see the brushes. I'm going to pull this apart and the brushes are going to pop out. But you can kind of see, if I get the light in there right, you can see where the brushes rub on the commutator. It pops out. We can see our brushes. So this part here is our commutator. It's where the brushes rub. And then these little guys in here are our brushes. Now these will wear out. They rub on the commutator the whole time this starter spins. There's little springs that help push them out, keep them against contact. These will wear. Eventually they can go bad and that can be a cause of a starter failure. Other causes of starter failure. Oil. I mean, if you've got back at the flywheel and the flex plate, you have a remain seal. It can leak and get oil inside the starter. An oil-soaked starter sometimes will not work. They won't make contact correctly, and that can cause a failure. So usually bushings will wear out in them, or you get oil contamination. Sometimes the windings inside the armature will go bad. They can short, they can be open. We also have our starter solenoid. So we talked on the cutaway, our solenoid, you notice all these copper windings. This is another electromagnet. So on this guy on the back side, you have two pretty big posts and one small post. One of these posts will go directly to the starter motor. The other one comes from your battery positive. It is 12 volts at all times. The little terminal is what energizes and tells it to kick on. So when you hit your ignition switch, you hit start, it's going to send 12 volts and go through a neutral safety or a clutch switch if it's a manual. That way, so you got to park or neutral in an automatic, or you have to have the clutch in to start. It sends voltage down to this guy. Those windings energize, turns into a magnet on the inside of here, pulls this plunger in, and that's what pulls on the fork that puts the starter drive out. It also makes contact inside of here between these two posts and sends positive power to that starter motor to get it spinning. I do, when I get to the school, I think I got a couple good starters there I can use. I'm going to show you guys how to bench test these starters to see if they function. Normally in lab, it's something we do. You guys have to pull it out of the vehicle, do a bench test to prove that it works, and then you'll reassemble the starter for a grade. Due to coronavirus, you can't do that this year. Next year when we get back, the seniors, this year's juniors, seniors next year, you guys will be doing a lot of this electrical stuff. We're going to review it again, refresh your mind on it. So that's all I have on starters for today. I will talk to you guys next time.